Hello, everyone. Thank you for being here today. So let's talk about what C3 does from an acceleration standpoint. C3 AI platform provides accelerators for the productionization and development of enterprise-scale AI applications. Let's unpack that statement a little bit. Since this morning, you've been hearing about a whole suite of AI applications that we have. We have about 65 apps across industries and verticals. What has enabled us to build these many apps and churn them out at this speed is we have built all these applications on top of the C3 AI platform. The C3 AI platform is a comprehensive AI application development platform that brings together all the different personas within your organization, gives them toolkits and functions which makes them more productive, but above all, it enables them to collaborate with each other in a very efficient way. In this session, we're going to specifically talk about what are the accelerators for data scientists, but as I said, I'm going to be going between data engineers and application developers a little bit, just to put things in perspective. So we'll start with data preparation, and we'll work our way through the rest of the stuff that typically we see data scientists having to do in their organization. You're probably having data in one of these data sources. It could be a database, it could be a data lake. You probably have data coming in from streaming systems and data warehouses and file systems and whatnot. Some of these logos there might actually ring a bell. And I'm guessing you probably have your infrastructure provisioned in one of the public cloud vendors or in an on-prem data center. Doesn't matter. What we see typically data scientists do first, and any of these roles which work with data do, is you're figuring out a way to pull all this data in and work with that data. That's where the first problem starts. Each of these data sources have their own format, have their own extensions, and once you bring it into whatever environment that you want, you still have some more processing to do. So the first thing that we want to solve for data scientists and anyone who has to work with data is, it doesn't matter what your data source is, what your data type is. With C3, you get a single unified interface to all your data sources and data types. Once you have this interface, you can access data from any of these data sources with APIs that look just like Python, and they can use those APIs to access data from any of these data sources, and it could be any data type. And this data has security federated all the way from the data source to the platform and to whatever application it is that you're building. So your data scientists don't have to worry about security. You as an organization don't have to worry about how do you securely make this data accessible to everyone in your organization. That's on the data exploration side. There are two ways you can go from here. One, you just use this data, this raw data, and you're doing exploration. You're doing proof of concepts, you're writing some Python code to see if there's any business value in building a use case with whatever data that you have. Okay, if that's what you want to do, the C3 AI Jupyter Lab extension, it's a one-stop IDE for your data scientist. So what's different between our extension and the open source Jupyter notebook that's out there? One, the open source ones, we have heard from our customers, it's very unstable, especially when you're trying to bring in enterprise scale data. So we've taken care of that, but we've done more than that. You get the C3 Generative AI Copilot, along with the C3 AI Jupyter Lab extension. What that means is your data scientists can just go ask very text-based questions, things that they would actually input on ChatGPT. They can do it from C3 AI Jupyter Lab. And it will give them answers which are relevant to your enterprise, to the data that your enterprise has. It can even generate code. If you see there, I know the screen is a little small here. All the ones that you see on the far left, which is green in color, is code generated by C3 AI Copilot. And you can push that code to your Jupyter notebook, test it out, and take it to production if you want. The second thing, increasingly we see data scientists want to do is decide what hardware they want to run their workloads on. Should it be CPU? Should it be GPU? If one or the other, what size should it be? They can configure all of that from Jupyter Lab. They don't have to go out of this IDE to do any of these tasks. The way we see it, this is your one stop. As a data scientist, whatever it is that you have to do, you either do it from here, or there's another tool which I'm going to introduce in a few minutes from now. Eventually, the third thing that data scientists will always want to do is, there are a whole bunch of ML libraries and runtimes out there. You want a tool which will help you manage the versions of these libraries and the versions of these runtimes. That is like fitted into Jupyter Lab extension at C3. From Jupyter Lab, you can do it all with the C3 AI Jupyter Lab extension. All right, so this is if you just want to do raw exploration on data. But you guys are in the business of building value-driven AI use cases for your company. We are in the business of accelerating that for you. What do I mean by that? If you know a specific use case that you are building towards for an AI application, with C3, you get off-the-shelf industry and application-specific data models. That hugely accelerates data science development. We have presence in all the 10 industries that the market typically tracks, and we have done every single use case across these industries. You could be someone in manufacturing trying to do optimization. You could be someone in oil and gas trying to do reliability. You could be someone in healthcare trying to do demand forecasting. For each of these industries and for each of these applications and use cases, we have been there, done that, which means you don't have to figure it out from scratch. We give you a starting point that's not here. We give you a starting point that's here so that your data scientists can start hitting the ground running right away when it comes to getting a data model that suits your use case and figuring out things that drives value for your business. And by the way, this is not just with data model. At every step of the way, we bring our industry and application knowledge to your data scientists so that they don't have to worry about figuring things out from scratch. That's what we mean by accelerators. So that's on the data model side. So what do you think is going to be the next challenge that data scientists have? It's usually governance. You have all this data coming in from all the different data sources. You have to make sure that this data is coming in the right format. And you also have to see what this data model looks like. You know, they say a picture says 1,000 words. That's exactly what's going on here. Meet C3 AI Studio. It's a UI to the platform. Everything that you'd get to do with the platform, be it setting up your environment, data exploration, feature engineering, model development, there is a UI for all of this that has been built for you, which we have seen is making data scientists very productive, both at C3 and at customers who use C3 to build applications for their business needs. Now that you have all the data ready, so you have found out a way to pull all this data from these data sources, you have found a way to actually visualize this with C3 AI Studio. The next step is feature engineering. You can continue to use the pandas interface that we have to do feature engineering. Here's where the challenge typically comes when you don't have a proper framework. Where do you store these features? How do you persist them? How do you read them back? How do you reuse? Well, we have taken care of all of that. With C3 AI, you get a feature store that makes it easy for users to define, store, reuse, and incorporate features across applications. If one of your teams has gone down this road, if they have figured out what are the right features for a specific use case, and if you're trying to extend that use case to other areas, to other sites, to other assets, they shouldn't be re-engineering the whole thing. Throughout the way, we are making sure that you are not reinventing the wheel at every step of the way. That's what each of these frameworks and components is trying to do. So with C3 AI Feature Store, you could have one team doing the feature authoring. If it turns out to be a great feature, they persisted in the feature store. You can decide who in your organization should have access to that feature store. And based on whatever security clearance they have, they'll be able to reuse these features for other applications as well. And as I said, we are in the business of providing accelerators. We take our application and use case context everywhere. So you get 200 plus pre-built application-specific features and the infrastructure to support it. What do I mean by that? So there are certain use cases where you have to compute features immediately because you're making predictions with your ML models, which are going to be used by the application for something that needs to be decided in that moment. Then there are certain use cases where, you are predicting demand. It'll be great to know the outcome of that immediately, but it doesn't have to be immediate. You can wait for the forecast to happen in a day because you're doing demand forecasting for 2 weeks out. The forecast results by itself can come out in a day. So how you compute these features is very important because you want to make sure you're using the right stack. From a cost perspective, you don't want to be computing features in a fashion where it's going to be very expensive if you don't need it to be very expensive. We have all these frameworks figured out. All you need to do is tell us what you want. We will have the right plumbing happen in the background to serve these features in the right way to you all. Okay, of course, there's a visual tool, right? For every step of the way, with C3 AI Studio, you get a visual tool for feature store and the feature to model lineage. You start with data, you did some data exploration, you did further engineering on that data, you arrived at features. The next step is you're going to feed these features into machine learning models. We are speaking with customers in EMEA with the whole EU AI Act. The entire lineage of what data was used to train the machine learning models in the first place is super important. Some of our pharma customers are telling us they cannot put a model in prediction without a tool like this because the EU expects them to have all of this documented. What features are used, what models were trained with what features, you need to have the complete auditability. Well, we have the tooling done for that, so you don't have to worry about any of the tooling to do any of this. Cool. Next step, let's talk about ML model development. As with every other area, you get 250 plus out of the box ML models and toolkits right away. So how have we gone about building these ML models? There are so many of these open source algorithms, and they are very good at doing what they say they're doing. Take TensorFlow, PyTorch, Keras, Scikit-learn. They're all very good for solving an ML problem, but that is not enough. They need to be able to solve that machine learning problem for your use case, for your industry. What we have done is we have looked at all these algorithms out there, and we have created ML toolkits on top of these algorithms by combining multiple of them that need to come together so that you don't have to do this dirty work of plumbing these things together. Time series construction, for example, very popular toolkit in all our reliability use cases. If you're having time series data, your data scientists are going to be spending a good month's time figuring out how to actually normalize that data, how to bring it to a format that you can then feed it to a machine learning model, and how to take predictions out of that machine learning model. Forget it. You don't have to do any of that with C3. We have all these ML toolkits, be it forecasting, be it generative AI, be it natural language processing, be it computer vision. We have done the stitching, and we haven't just stopped at that stitching. We have brought in all our industry and application knowledge across these industries together to make sure that whatever models that we have available is applicable across industries and for specific use cases in these industries. That's the value add we provide from an ML modeling perspective. Pipelines. I won't say this about every functionality that we have, but I'll say this about ML pipelines. We have the best ML pipeline in the industry, period. I'm not the product manager for ML pipelines, by the way. I have a data science background. I've had to use ML pipelines across many tools. I personally love C3 AI ML pipelines. It's clean, The interface is so cool. You can stitch as many ML pipelines as you want. The whole composability of these ML pipelines, where it's still industry and application specific, but very easy to plug and play, just makes the life of a data scientist so much more easier. And you can have any type of data, multimodal data feed into this ML pipeline. You can have any type of output, predictive, generative, optimization. The platform is your playground. Go have fun. That's the story, across the board, but specifically so when it comes to ML pipelines. Because ML pipelines is the biggest challenge once you start getting out of your data realm. That's the challenge that we had to solve for our customers from the get-go. So this is something that we started designing like 5 years ago. This is our third time redesigning ML pipelines and making it available in V8. I guess third time's the charm, when it comes to ML pipelines. So we have really figured the thing out with ML pipelines. Finally, as with every other feature, the visual tooling. With C3 AI Studio, you get end-to-end visual tooling for ML pipelines. You get to see what data was used to feed to a pipeline, what are the different parameters of a model, what all ML models were packaged together for machine learning pipelines to work seamlessly in production and exploration. You get a visual tool where you can see all of this. So you code your way through stuff if you want to, but if you want to be able to communicate with other teams within your organization who may or may not understand your code, you don't have to sit and write documentation. The tool is your documentation. It has a pictorial representation of everything that you do. And all you have to do is make this available to them for them to see what's going on. All right, finally, let's talk about model operations, my favorite topic, because I've been a data scientist for about 7 years now, and I've still not figured out, after speaking to so many customers, if model operations is a data science job or if it's someone else's job. Lorenzo is like winking his eye here, so that's because, at some point, you are, as a data scientist, going to hand off your work to the other teams to take things forward. That's usually the operations side of it, right? The name ops by itself makes it feel like it's not my job, it's someone else's job. Well, we'll put the debate on whose job it is for rest for now. With C3, you get a model deployment framework and a model registry where we have standardized this entire thing with the UI. As with everything else, you can code your way through it, but then why do it? You have a visual tool. You can see the entire set of models in your industry, in your company. You can test different models, so the whole champion, challenger, candidate model framework comes with the tool. You can add more parameters if you want to it. So you can have a model in production. The cool part, the reason I like the ML side of it is, once you put things in production, the question you're going to have that you need to answer to yourself is, once a model deteriorates in production, once there is some problem with the machine learning model, how do I swap that model without bringing my system down? My business cannot take the impact of an application going down. I need to figure out a way to swap models underneath it and still have the application up and running. You can do that with C3. Our customers do it all the time. They have multiple models running. One is in production. The remaining ones are getting tested. At some point, if they see that a model is doing better than the other model, they just swap it. The whole framework is there to enable them to do that. Once you have deployed this model, next comes model monitoring. The data that's coming into your system could be corrupted. Corrupted data just means your models are not going to work very well. Data is the source of truth that's actually feeding into your model. The model is making predictions based on that data. At every step of the way, governance is important. Data drift, C3 AI will actually notify you about it. Model drift is if there is a recall or a precision problem, C3 AI Studio will actually notify you about these things. So the entire model monitoring framework has been integrated into the platform. But wait a second, going back to the point that I was making before, which made Lorenzo wink his eye. If you don't want to be doing this as a data scientist, if you want to have your end users, your business users do this, you can do that with C3 very easily. You can empower your business users to do model operations. This screen that you see here, that's C3 AI reliability. Have you guys heard of C3 AI reliability? Okay, a lot of heads nodding. That's our most popular application that we have deployed in multiple industries. This green box that you see here as part of C3 AI reliability is actually model operations. We have integrated the entire model ops as part of the end application so that folks who are actually using the application, the business users who are sitting in refineries, they can be the one deciding which model to deploy to predict the failure of a control valve or whatnot. So where did we start? We started with this. This is the data. You have data in all these different tools and databases and data sources. And each of these vendors have their own set of tools, Databricks, Snowflake, AWS, Azure. They give you a tool which gives you access to the data that you have stored in these respective technology stacks, but that only gets you so far. You can probably do very good exploration with that tool, but if you want to do more than exploration, you need all these blue boxes to come together. You need a unified data model. You need a feature store. You need a way to develop ML models, and you need a way to deploy these ML models and finally make them applications. The question you want to ask yourself is, what business do you want to be in? Do you want to be building all these blue boxes and figuring out the dirty work in maintaining it, plumbing it, and having it up and running? Or do you want to build use cases and applications which provide AI-based value to your business? If it's, I want to provide AI-based value to my end business, then we are having the right conversation here. As I said, you don't have to take my word for it. Everything that I did in the last 15 minutes is just the opening act, where you can hear it from our customers who have gone down this road of using the platform and being very productive with the platform. So ladies and gentlemen, please welcome Mehdi, Jorge, Lorenzo, and Vivek to join me for a panel discussion here.
Thank you, Shiva, and thank you all for listening and for being here. I hope you're having time to enjoy Florida at least a little bit. We've been in the conference, and it's been hopefully a substantive first day. So my name is Mehdi Masumi. I'm Vice President of Data Science at C3 AI. I've been with the company for more than 10 years now. And over these years, I've had the pleasure of working with hundreds of customers like you to help them along the journey of bringing their prototypes and applications to scale them out and scale them up across assets and applications. And we're fortunate to have 3 of those wonderful customers here with us today. I would like to start with a round of introductions, and then we go to questions. Please.
Hello, everyone. Thank you for the invitation to be here. It was an amazing experience so far, and I'm Lorenzo Lancia. I'm a lead data scientist at ENI in the Digital Center of Excellence in the Technology Department. I joined the company 6 years ago now, and I've been working on applying machine learning and predictive analytics to our upstream business since then.
Thank you.
So thanks for the invitation. So my name is Jorge Gamarra. I work in Holcim. I am the head of maintenance technology for the group. I have 18 years in the cement industry. My background is automation engineer, and I lead in a group of 5 data scientists, which are basically programming the C3 platform to monitor the condition of our machines in the cement plant.
Okay. Hi everyone, my name is Vivek. I work for Shell. I'd been with Shell for about 8 years. I'd been associated with the C3 predictive analytics program at Shell for over 4 years now. We have built about 8 products on the platform, custom solutions on the platform. We have over 19,000 machine learning models running for a similar volume of equipment across the globe, Shell assets. I have personally built apps myself. I now don't find time to do so, but I manage a bunch of app developments. That's in a nutshell what we do. Thanks.
Thank you all. Wonderful. So starting from Vivek, I've known Vivek from 2019 when we met in Bangalore. So we had just finished building 2 applications when we started the C3 Center of Excellence with Shell. We built the first 2 applications and we started to ramp up, essentially taking those to the assets and deploying across the assets globally. And that's when we went to Bangalore to train the team they had in Bangalore, and that's how we met. But even before that, when we started our engagement with Shell, I remember that you guys had built applications, right? It wasn't that you were naive or hadn't done anything. You had actually been using AI and been using ML algorithms. At the time, I believe you were using Databricks and you had R-Shiny UI, and you even had hundreds of models live in production.
Yeah.
So my question to you is, what was missing really at that point, right? That you essentially reached a dead end, that you couldn't scale beyond that point. What was it that was missing? And how did C3 provide that functionality to you and the Shell team?
Yeah, Shell has had a statistics practice since the 70s. As Mary mentioned, we have had a lot of pockets of isolated machine learning AI solutions across Shell. There were no synergies that we could draw from them. They were limited by infra that they could run on. We were on a lookout for scalable AI solutions to be built, and C3 came along quite well. That's kind of a triggering point for us to look at our AI landscape and try to formalize how we would want to take this to scale. There was a lot of opportunities that we are leaving on the table. So we tapped into that. That's how this whole practice started. We started out very small, 2 or 3 data scientists trying to get trained on C3. But now we are at over 40 data scientists and data engineers and still growing. Yeah, that's our journey over the past 4+ years.
Thank you. Do you want to talk about the differentiations that you see in C3 versus the old system that you had, or other platform, open source or other tools that you were using? Yeah. What enabled you to go so fast?
2 things. One is running AI workloads at scale. C3 has proven to do that quite efficiently. The other advantage is standardization. How do we standardize AI workloads across a company of the scale of Shell? How do we run them seamlessly? How do we draw in synergies from having a standardized data model, running it across apps? Those kind of expedites your development time, brings about a company-wide standardization, so to speak. You can imagine the value benefits, the time benefits you could draw from having such standardization.
Thank you. And I've known Lorenzo for about maybe 3 years, a couple of years now. Yeah, we started with the first call when we had a code review, essentially, of what they had been working on. Right? They had built 4 custom applications with Lorenzo and his team, and those applications were live. They were, working applications. But again, just like Vivek and his team at Shell, they reached a point that they realized it's not sustainable, it's not manageable, and the complexity is growing. So maybe you want to also talk through, and I remember, by the way, I was really impressed by the code quality and the whole object-oriented programming that you had implemented. It was a very neat code, but still, even if you have object-oriented programming at the code level, at the machine learning level, I'm curious, what was missing really that didn't allow you to continue down that path and you decided to come the C3 way?
Oh, thank you, Mary. So the point is very simple. We started with those applications that were live and that were running. They were used by our people. And among here, there are colleagues that are working with those old version and new version on C3, so they can tell the difference. And the point is that there was a lot of effort involved on our side to build things that works with the right timing, with the right effects. And at some point, the headcount needed to keep those applications alive reached a point that it impacted our capabilities to continuously increase the adoption to other assets, to other use cases. And we started to think what we could do. I mean, at that point, AI, machine learning platforms were a thing. When we started, there was nothing available yet, or if it was so premature that we decided not to go that way. And the code you see, that you tell, it's very nice because it was designed to be ready to be put on a, let's say, cloud vendor machine learning application. But again, even all the applications are a layer on which you have to build things on top. What the differentiation between one another is how high the platform going to bring you and how you have to build your own things. What we realized was that even with better code, even with a better platform, we were still required to build a lot of things without even thinking about the model operation. So with those problems in mind, we started to think we need a higher level of abstraction. We need something that remove a part of the work from us, that give us something to work on, not to work within. And that's why we came from C3. I mean, it's the same when I ask people, why you choose C3? I always answer them with another question. So why data scientists work with Python? No? It has an hidden cost, which is pretty obvious. It's slow with respect to other compiled languages. It's not hard typed. It's prone to error. You cannot check errors unless you go in runtime. So why you do that? There are a lot of downside to choose Python. The reason is because give the practitioners, the Python practitioner, a higher level of abstraction, and with the time they have, they can build things that have more value. And that's the same exactly reason where we, because we decided to go with C3.
Wonderful, wonderful. So as I hear, as complexities of building and maintaining applications across the enterprise grows, in order to maintain that complexity, you need abstraction layers. You need to abstract away those complexities. And that's why Lorenzo and his team have adopted C3. And we will come back to where you are in terms of scale as a second question. But before that, I want to go to Jorge. Very fascinating presentation this morning from the whole SIM team. We all saw very ambitious goals in terms of the factories of future and so on. You guys are experts in cement and building material, but you still, and you've been working with these assets, right? The machines, you're an expert in those machines. And you've tried to actually build predictive maintenance solutions yourself in-house. Maybe walk us through that journey as well. And was it similar to the other folks on the panel, your journey, and what led to adopt C3, and what are you seeing as differentiations on C3?
Yes, so our journey started like 6 years ago. And as you said, we first attempt it was, okay, we developed everything from scratch by our own team. Actually, I was involved from the first beginning. In the first year, we were relatively good. So we managed to create, let's say, around 80 applications. So 80 applications for the audience and for us is a heavy machine, like the picture that you saw it this morning in the presentation, which have a lot of subsystems inside, which means each subsystem have one or two models which are monitoring the subsystem, and then you have one complex. It was very good in the beginning, so we were very excited because the thing looked that they started to move very well. But in the company, we have a small issue, so we have a lot of machines. And the multiplication, it became very complex and very costly because we need, as it was application homemade, and we need to use open source, and we need a lot of people to program, a lot of experts. The cost is quite a lot. So until certain point we decide, okay, now we need to look for something more professional and from the shelf, which can remove a lot of tasks. So especially when we look on structuring the data, standard models, visualization, that if we can easily multiplicate in the different machines. Then we start to make a research. Well, then we arrived to C3 and we saw it, so a platform that helped us or have all the qualities that we were looking. And so to give you an idea how we had automated the process and how we reduced the time of creation, that for us is quite important. So for one machine to build one application in the past with our own garage approach, it was around 100 man days. So from the moment that we get the data until we have the system deployed at the plant level and the guy in the plant can start to use it. Compared with C3, we bring it down to 7 days. So for us, it's a huge improvement. No? Of course, we reduce as well the size of the team. So we were with a team of 50 people, and now we have 6. So 3 data scientists, 1 or 2 developers, and 1 or 2 data engineers, and that's it. And if you saw it in this morning, so the scale up this year is quite high. So we look for only this year is 250 machines from only 3 types, but this is growing. And until we reach an amount of around 4,000 machines in the 4th year. So, but this is thanks to the platform of C3.
Wonderful, wonderful. Thank you. Thank you for taking us through the journey of where you started 6 years ago, the garage approach, right? And then moving on to C3 and scaling. And as we saw in the keynote presentation, you have very ambitious goals of having 1,200 systems, right?
Correct.
Which are indeed have subsystems within them, and each subsystem might have multiple models. So we're talking about thousands, if not tens of thousands of models in production. So I see a competition between Shell and Holcim in terms of number of models in production. So I like it.
Actually, we're learning from them.
You're learning. Fantastic. Thanks for those quantifying the benefit. I would like to also hear the same story from Lorenzo and Vivek. Can you quantify for us the improvement in the speed of development that you're sensing with C3 versus without C3 before, in terms of efficiency of your team, right? And in terms of time to value? Can you give us some numbers?
Yes. So I can give them because that's a challenge we face together. Now, when we approach C3, we say, okay, to define this project as success, we need to hit those metrics. And those metrics were not, like Olsen presented today, were not related to the quality of models. Because for our application, we know their performances in terms of accuracy and precision. What we needed was metrics that describe the capability to scale up those applications. And we measured them on one of the most important application that we developed, which is Phoenix, which is an internal tool for anomaly detection for critical machinery, which for an oil and gas company, let's say it's like no-brainer. The first thing you go with machine learning, because if a turbo compressor breaks down, there's a lot of money involved. And we before C3, we arrived to encompass with applications something like 30, 40 turbo machinery, turbo compressors and turbo generators. And to retrain one of them, it took more or less than 1 day of a data scientist's works. And I mean, we are 20 now, and not all of them are working on upstream. We have a lot of projects throughout all the businesses of E&I and all the support functions. So removing one person for be there and retrain models was not a very wise use of people. And we say with C3, can we reduce it to 1 hour? We measure it and we eat 55 minutes with the chronometers. So
beautiful, 24x improvement.
Yeah.
Thank you so much. So yeah, as Lorenzo mentioned, really the power of reusability of software components, the abstractions, and reducing the complexity enables you to do more with less, right? Enables you to do more with the resources you have, put them in the right place, have them, as Shiva mentioned in his presentation, be in the business of solving the business problem as opposed to rebuilding the pipelines and the pipings, which may or may not be really the core competency of your company as an oil and gas company or a financial company or a company in the cement business. I want to go back to Vivek also. Give us some numbers in terms of how long did it take you guys to build and scale apps before and after C3?
Yeah, initial days, we didn't have a standardized data model. I would like to make that distinction. We quickly moved to the reliability data model for our predictive maintenance suite of apps and beyond. So that kind of provided us a jump start in productizing use cases. So we are now able to productize use cases roughly in about 3 months, which used to take years, and it did not have the applicability, the reach that it used to have before C3. In terms of developers, we are a COE of about 40 to 45 data scientists, data engineers, app developers. We have 8 apps running in production at scale. So roughly 5 to 6 devs is what we have in the team. What we were able to do with our predictive maintenance apps is that we kind of passed a lot of model management, model governance, and value realization to our process engineers, reliability engineers, rather than data scientists having to do that. We don't have quantified numbers on the level of effort they would have spent it, but it wasn't, as you can imagine, it wasn't sustainable if a data scientist were to do model governance, model management and such. So that I believe was possible because of the abstraction and the type system C3 provides that kind of helps us abstract things under the hood and kind of provide what really matters to our process engineers and our asset users.
Focus on what really matters.
Yeah.
Fantastic.
Can I add to Vivek's point? I mean, we've been around for 15 years. Our engagement with Shell has been 6 years. But I can safely say they've played a big role in influencing our roadmap. And that's true for E&I, and I know that's going to be true for Holcim as well as we start engaging. So it doesn't matter when you start working with C3. We are so customer obsessed where at one point you don't realize whether it's your roadmap or our roadmap because it's one and the same. And we would like to be at the same place with all of you here as we look towards the future. Mehdi.
Awesome. Thank you. So we're almost up with time, but if there is questions from the audience, we would love to take 1 or 2 questions. If anyone has questions on the topics that we discussed. Yes, please.
Can you go to the mic just so that it gets recorded? Sorry about that. Yeah.
Did you have existing infrastructure that you had to replace with this? Did you already have an AI stack? Did you get rid of things and put this in? And how did that go?
Thank you.
So the very first version was built on big data infrastructure. So everything was based on what was Cloudera. We were one of the first Italian customers of Cloudera. And we are still keeping it, but planning to remove all of our AI application and keep it only as a data lake for some legacy reasons.
In our case, so cement industry is quite rare to have this kind of infrastructure before. But in Holcim, I think it was a cultural thing we have created since the last 20 years, a heavy infrastructure to collect it. So for us, that was the best base to start with this kind of, let's say, test in the beginning. The other thing what we have defined is a very clear architecture for the infrastructure, how the data need to flow, where. So in our case, for instance, we work in a hybrid model. So because the allocation of the cement plants not allow you to have everything in the cloud. So we have a hybrid model. So we work in the edge for certain applications and for certain models. And we have certain data which we bring it to the cloud, which will not affect at the plant level or the machine level. So this we define it very clear. So 6 years ago, and this one we ran it. Also, as I mentioned, this infrastructure that we have from the past, which was very robust, allow us to come with this hybrid concept of this thing. So that was very good.
Yeah, in our case, we were kind of early birds on the C3 platform. We haven't been doing a lot of at-scale implementations, AI implementations at Shell before C3, so it was not too tedious to set up new infrastructure on C3. We didn't have to migrate or such, if that's your question.
The more generalized response is we always have a better together story with data vendors and cloud providers. Mm-hmm. What that together means is dependent on who that provider is and who that infrastructure owner is, Azure, AWS, GCP, and what is it that you have in them. You can leave all your data in Databricks and Snowflake. You can have a virtual data model. Yeah. You can pick and choose other features from these other platforms if you want. As long as together, if you're landing at a better place, we're game for it.
Awesome. Thank you. One more question.
Yeah, we can take one more, yeah.
When you're rolling out to these applications, or some obstacles you have to overcome, or something you have to change, both internally or externally with C3. Thank you.
Thank you. What are some of the obstacles that you faced and solved along the way in your journey?
Yeah, I can probably go first.
Yes.
When we started out, the learning curve was quite steep for our data scientists. It was more so a shift in mindset, I would say, kind of letting go of things they were used to keeping close to them. So it's more of the mind shift, I would say. Besides that, we kind of, at the start, we were kind of scrambling to get our data in order, kind of streamline into the pipeline. That's why I made the distinction that once we adopted to the reliability data model, things were much smoother. But until that time, we kind of had a bumpy ride in terms of getting our data unified within C3, following a standard data model to not duplicate efforts and such.
Vivek, can you also mention about the whole pandas-based interface that came from Shell for DS onboarding? The type you wanted an interface that they know, and we picked it up.
Sure. Yeah. So, of course, every data scientists are pretty familiar with Jupyter Lab, Jupyter Notebooks. That's kind of their bread and butter, right? So having a Jupyter interface within the C3 platform was kind of their step into the platform.
Yeah.
So they kind of got familiarized with the platform that kind of allowed them to work with a familiar IDE within the platform while they connect to data sources that is C3ized, I would say. So that kind of made the transition a little smoother. I would say it's, yeah.
Thank you. I'm getting the signal that time is up. Thank you so much, everyone. Really appreciate your time. One last comment. Last year, when we did the same session, we had not started our collaboration with the whole team. We were early on with ENI, and we have them here on the panel. I would love to have some of you guys next year on the panel, hopefully doing some great work together. Thank you.
Thank you
so much.
Thank you.